Hi, everyone. Thank you so much for joining our second ever Learning Labs. We're so excited to have you all here. My name is Kirby Koo. I work on the marketing team here at Chainguard Driving Community Growth. Today, we have a really exciting session with Maurin Berti, who is our senior software engineer here at Chainguard. He'll be showing you how to switch to Chainguard Java images. Before we get started, I just want to do a little bit of housekeeping. I just want to direct your attention to the right side of your screen. There are a couple of icons there. The first one is the chat icon where everyone is currently typing where they're tuning in from, so be sure to do that. The second icon there is a little chat icon with a question mark, which is where you can submit your questions, just to make sure that we get to every question that you might have and that we are able to track it. And then finally, it's the Java image. So we're doing a little Java surprise. The first 5 people to fork and complete the demo and send a screenshot of it to me will be receiving a small Java surprise. If you don't know, Java also means coffee. So we'll be sending you a gift card so that you can enjoy Java or a cup of coffee anywhere you are in the world. So I'll put that in the chat as well, so you can follow up with that and my email there, so you can reach out to me for that. So without further ado, I am going to bring Maurin on the stage, and I hope you guys enjoy the show.
Hello, everyone. Thanks for joining the session today. Gonna share some slides here. Everyone can see that. So again, thank you very much for joining the session. We're going to be talking a little bit about building secure Java images for applications using the base Chainguard Java images. It's going to be a rather high-level introduction. So you need to know just a little bit of Docker and a little bit of Maven. Um, you will need access to a text editor if you want to follow along the demo, and a terminal for running Git, Maven, and Docker commands. So my name is Maureen Bertie. I'm a software engineer here at Chainguard, as Kirby already introduced me. In my past life, I have worked for quite some time as a Java application developer, and I moved a little bit in 2019 when I started to work more in the platform cloud native world. I don't have much of a presence in social media, but my email is up there if you want to connect. And I also have an account on LinkedIn if you want to connect there. So, our agenda for today is gonna be an intro to CVEs and what are Chainguard images. I'm gonna talk a little bit about the example application and the example image we're gonna be building. Then I'm gonna do an example on how to migrate that image that is not gonna be a multi-stage build at that point to the Chainguard equivalent. First using upstream images, then going to the Chainguard equivalents. And for the last part, we're gonna talk a little bit about multi-stage builds. I am going to stop for questions at some points, but feel free to send your questions via chat as well. So the prereqs for the demo are going to be Docker installed. I personally didn't check it on Podman, but I suspect it should work. You're going to need basic container knowledge, so if you have done Docker build and Docker run, that should be enough. Git installed if you want to clone the repo and follow along. And Maven installed because we are going to be running some Maven commands directly on the machine instead of running inside of a container. Before we continue, let's talk a little bit about what is a CV and why it's a problem for a lot of people and organizations. So CVEs, the acronym stands for Common Vulnerabilities and Exposures. They are essentially known software flaws, and they have a security impact on applications. of them can be very significant, and you have probably already heard of CVEs like Heartbleed that affected OpenSSL a while back, and perhaps Log4Shell as well. That Log4Shell vulnerability affected the very popular Log4j library, and it's especially interesting for today's subject because it has specifically affected the Java ecosystem. Um, this is a good example of how such a vulnerability can impact an environment because Log4Shell made it possible for a remote attacker to take control of a device over the internet. So this led to the birth of security tooling like Trevi, Gripe, and Snyk. And those tools scan container images for known vulnerabilities and produce a report. Ideally, we would like to have a clean report for every image, but sometimes it isn't possible because a lot of images published on Docker Hub already contain CVEs. And this has left a lot of organizations unsure where to go next because you would like to get rid of the CVEs, but it's hard to know where to start. And this is where the Chainguard images come in. We try to eliminate those challenges, by getting rid of all the CVEs or all the known CVEs in the open source software that you consume. So our images are low to no CVE, and they are minimal and hardened. Our images are designed to be secure and provide a secure basis for efficient application development. And we rebuild those images daily and have images for a lot of ecosystems, such as Java, Go, Python, also some third-party open source like Postgres, Nginx, and Redis. And there are also options for FIPS images. And we have different image tiers. Everything that I'm gonna be showing and presenting today is in the free developer tier. But the caveat is that everything that you're gonna get in that free tier is latest tags. For free developer tier, images are also available in Docker Hub under the Chainguard org. And if you need a specific version of an image for any reason, that will be available on a subscription basis only. The same applies for special images and FIPS images. So in this slide, we have here a comparison for some popular images, such as Maven, where the Chainguard image has no CVs, and it's about half the size of its upstream counterpart. Node, the Chainguard image is about 44 megs, and we have no CVs as well. The upstream is around 1 gig. The upstream Ruby image is around 900 megs in size. The Chainguard equivalent would be much smaller at 50 megs and with no CVEs as well. And Golang has an upstream image that's sized around 830 megs, with the Chainguard counterpart sized a little under 700 megs and with no CVEs. So if you pay for the production images that Chainguard provides, you will get an SLA for resolving critical and other CVEs. The critical SLA is of 7 calendar days, and the remaining CVEs is 14 calendar days. The data I just showed, it was pulled this March, so the vulnerability data should be from around March 18th, and the size data is from this week. Do we have any questions so far? I'm gonna move, but we can come back to if there are any questions later. So I'm gonna show a little bit of practice now. If you wanna follow along, you will need to clone the repository that I have on the screen here. Feel free to fork that and go ahead and clone it locally. So we are gonna be using that in a few minutes. gonna stop sharing. What stops the free images from getting old quickly? Is there some check for any development packages that a developer installs? I'm gonna have to get back to you on this. But this is an interesting question. So I'm gonna dive into protocol a little bit now. Feel free to follow along. First off, let's talk a little bit about the application that we have in that repository. So it's going to be a simple Spring Boot application, and it's just an API. So it's just going to be one endpoint that responds something to us. If you're familiar with Spring Boot apps, this is not going to be a huge surprise for you. So we have a source folder. Show here the tree for source. We have our source folder that follows the usual Maven structure. This was generated by Spring Initializer, so it should be fairly familiar. And we have here the Hello World application, so I can show that. Chainguard. So this is very simple. It's just your regular Spring Boot app, nothing different. And in the controller side, we just have two endpoints. The /1 that doesn't respond to anything other than an OK status, and the hello endpoint that is going to respond hello world. So let's change this. I'm gonna do it, make it respond hello learning labs instead of hello world. And what we are gonna do here is build it using a Dockerfile. So for the time being, what I have here is just pulling upstream Maven. I'm gonna copy the source and the POM, and then I'm gonna do an MVN clean package. Afterwards, I'm gonna remove the whole repository that was generated by Maven, and then we are just gonna copy it to a separate folder. This demo is using Java 21, so the latest Maven, last I checked, was using JRE 21 from Timirin, and the application is compatible with Java 21. Build this. Before we go, I'm just gonna show the POM XML file. This is what it looks like. Sorry, it's just your regular Spring Framework boot starter with a starter web, because we need information here from starter web to be able to create a RESTful API. To build this, I'm just gonna use Docker build. I'm gonna call this Java demo app. I'm gonna tag this as the hmaven. And it's gonna take a little bit to build. But what we are gonna do here after this application is built is we're gonna just test it, make sure that it runs, and then we are going to check for CVEs and see what happens. Now we have Java demo app built here. It ended up with about almost 600 megs. When we do Docker run, I'm gonna run this as demo application. So dh maven. We can curl. I'm exposing port 8080, so when I do curl turbos, we can see that this is responding with 200 OK. And then when we do hello, it's going to respond with Learning Labs. So in terms of CVs, what does Docker Scout has to tell us about this one? So we have about 28 CVs here. Let's see what Gripe tell us about this. If Gripe agrees that there are some vulns here. So we also have some vulns here, about 77. If we make this same Dockerfile consume our Chainguard Maven image instead of the regular upstream Maven, how will that impact the end result on CVEs? So I'm gonna change our regular Maven for cgr.dev/chainguard/maven, but this could also have been just Chainguard Maven from Docker Hub. Then I'm gonna redo our Docker build. I'm gonna tag this as cg maven instead. Is Corrado JDK version of images also available with Chainguard? I don't think so. Our JDK images right now are open JDK. I did forget to stop my previous container, so I'm just gonna do that right now. Let's run this and see. And our result is similar. We also see Hello Learning Labs expected. Let's take a look at Docker Scout quick view in this image. And we have no vulnerabilities for this one. Does Ripe agree with that? And yes, we end up with an image that has no vulnerabilities. On the size front, this is a bit smaller than the previous one, so it has around 343 megs instead of the previous 585. I'm gonna stop this container now. And another thing that we can do, so when we built this image and I used Maven as my base image, what ended up happening is that the whole build environment makes its way towards the final image. And we usually don't want that because that can expose us to extra vulnerabilities, and other security issues. So it's a good idea to just have an image that is going to be as minimal as possible as the result. Um, to do so, one thing that we can use to get to this result is a multi-stage Docker build. I can convert this Docker file we currently have, so I'm gonna roll this back to the Maven image we had before, and I'm gonna use an alias here for this stage and call this builder. This is the image that is going to build our application, but not the image that is going to run our application. Here, right after the repository statement where we remove the Maven repository, I am going to add a new from clause, and I'm going to build this second step using the Eclipse Timuring 21 GRE image. I'm going to call this a runner. And here on the where we had the copy, regular copy before, we are not going to do a copy clause with a from parameter where we specify builder. So this is going to copy the jar file from the previous stage into this next stage, and it's going to result. It's going to give us a different result from what we had before. So let's take a look at how would that look like. We're just going to do the regular build of a demo app. And I'm going to call this Timuring GRE because that's what we are using for the final stage. So on size, what do we have here now? Our Timuring GRE image is going to be even a little smaller than the previous one. So it's going to have 306 megs. We're going to do Docker run here as well. We can see that this works as expected. Oh, I forgot to my previous container. Here. Okay. Work now. So now if I do co-host 8080, no, same response as before. As for CVEs, what's gonna happen here? One has, I think, one CVE less than the previous one. It has 27. If I recall correctly, our previous one had 28. What we have for ripe, see if it also goes down. So it's also a little bit smaller. It's going to be 75 instead of 77 as we had before. But what if we migrate this to use Chainguard images on both builder and runner environments? I'm gonna pull this from Docker Hub this time around. And here, I'm gonna use Chainguard GRE. Our current GRE, our current latest for GRE is gonna be 21 as of now, as of today. So this should still result on a Java 21 environment. And we're going to call this CGGRE. Let's take a look. Java demo app. Our resulting image for CGGRE is going to be around 268 megs, so even a little bit smaller than Timurin. And when we run this, we should get the same result as before. Hello, Learning Labs. Do a Docker stop. This. Then we'll check with view. We have 0 CVEs on Scout. And about grape. Also 0 CVEs. So this is the end result if we use Chainguard images. That's how that's what we can get by using Chainguard images. Gonna stop sharing my terminal now and go back to the presentation so we can a little bit about the results. So to recapitulate our build data, building our sample application with the upstream Maven image resulted in an image that was upwards of 500 megs and with about 77 CVEs. When we built the same application with the Chainguard equivalent, the size dropped. It was around 343 megs, and the Chainguard equivalent has no CVEs. If we compare the version where Maven is not carried to the final image and we use Tamurin, our image size fell to 306 megs, and it still has, however, 75 CVs. But the Chainguard equivalent results in an even smaller image at 268 megs and no CVs. Any questions before we proceed? Okay, moving forward. So there are other tools that you could use out there that allow you to build images and don't use the Docker build command. And GB is one such example, specifically applied to the Java ecosystem. So it is a tool that's hosted under the Google Container Tools organization in GitHub, and it's meant to generate optimized Docker and OCI images for Java without the need to access a Docker daemon. And we can take a look at how this would work. And this is going to be another bit of the protocol. So I'm going to go back to sharing my terminal in a second. What we are going to be doing now is using Maven to generate an image using this Jib plugin. Jib can be used via CLI, Gradle, or Maven. I'm going to be showing Maven today because that's what my application is using, but it should work with other tools as well. We are back to my terminal here. Let's clear this. And let's do. So what's gonna happen here? We took a look at the POM file before, but I didn't get to talk about the build plugins. So in this build plugin section here, I have the Spring Boot Maven plugin that's going to generate us the jar file. But also we have this other plugin called Jib Maven plugin. I'm using here version 341. And I have configured it specifically to build the ARM64 architecture because that's my platform right now. But if you're building this towards a registry, you could use this configuration to generate a multi arch image instead. And in the from section here, I specified the usage of cgr.dev/chainguard/jre as our base image. So I'm gonna tag this as Java demo app at jibcg, so we can compare against the other Java demo apps we just built. And the way to use this tool is via the mvn command. So I'm gonna do a clean compile, and then I'm gonna do jib docker build. And if we do Docker build, this is going to build the image against the Docker daemon. The other option is doing just build and building it against a registry instead. I don't have a registry configured right now, so I'm just going to use the Docker build. And then if we do Docker images, Java demo app, going to have jibcg here. It has the same size as the one we built with the Dockerfile using base Chainguard JRE image, but that timestamp is going to be zeroed. If we try to run this, then we should also get the same hello response we had before. And as for CVE's comparison, it also has no CVEs. Right. Also tell us no CVEs. So it's about the same size, and it's not about, it's exactly the same size as our previous build with the Dockerfile in multi-stage build, and yields the same result CVE wise and application wise. Back to the slides now. So quick recap. Building with Jib yields the same result as if we had built a multi-stage Docker build using the JRE, the Chainguard image JRE. And it's more of the decision between the two would be more relating to what your environment needs. We're gonna move now into debugging JRE only. Um, so when using the Chainguard image for the JRE, you're going to notice that a lot of tooling is not available. For instance, you're not going to have a terminal, so you're not going to be able to just shell into the container. And if you need to debug, that can cause some difficulties. Um, if you need to get to this point where you have to debug, what can be done? So one way would be to rebuild your image, but use the latest dev variant of that same image that we have available. This image will now have some tools available, such as a terminal, and we'll take a look soon at how to do it. Another option is available, but I'm not gonna be demonstrating today, include using Docker debug. And a third one would be to use Kubernetes ephemeral containers. If you have your containers running as a containerized workload in Kubernetes. A little very brief introduction to what an ephemeral container is in Kubernetes. Is this is a stable feature that is available since Kubernetes 125, and it allows you to add a new container to a pod at runtime through the use of the kubectl debug command. This has the goal of allowing user-initiated actions, such as debugging, and it makes it very useful for troubleshooting applications. Because of time constraints, I'm not going to be showing how it can be done, uh, but just meant this as more of a informational slide that this is a tool that could potentially be used if your container is running as a workload in Kubernetes. We're going to do a little bit of practical on this. So I'm going to talk through how to rebuild your image and how you could use that to debug an application. Um, so I'm gonna share once again my terminal here. So if we go ahead with our previous Docker file and we change this from Chainguard GRE to GRE latest dev, we can now do another Docker build in the same image. I'm gonna call this CG GRE dev. So as a means of comparison, look at what we had here. We have the CGGRE. This is about 268 megs, and now we have the CGGRE dev, which is about 299. If I wanted to start a container in interactive mode with the previous image we built, so we would do something like -it. I'm gonna pass an entry point here, then do Java demo app CGGRE. This is not gonna work because the shell is not there. But now I just rebuilt my image using the dev variant. So I can rerun this using the new tag, which is cg-gre-dev. And the entry point is now going to be available, that shell entry point I wanted. Say that I need to debug for whatever reason, and I want to run this using java-jar directly from the terminal. I could now do that, but also you can gain access to other things. I think I'm not gonna have like file available here, but I could have file available, for instance, or you could install other tools as well. So if I wanted to run this as a different user, let's say root, I could potentially apk add the file, and now I can check that my demo app is the kind of file I expect to have, or install other tooling that you might need here. So this is one way that you can use to debug an application. Um, Granted, it requires rebuilding the image, but it gives you one way of investigating what's going on once an application has been containerized. Going back to our slides. Let's talk a little bit about how Chainguard keeps out CVs. So the strategies we use for that is cutting down dependencies, keeping things um, as up to date as possible, applying patches when needed. So sometimes when a CV has been patched upstream, but for some reason a new release has not been cut yet, we will apply those patches downstream. And we sometimes also issue security advisories when upstream projects determine a CVE to not be applicable or not exploitable for some reason. So this is all the content I had for today. Just to wrap up and recap, it's quite simple to change to use your container files, your Docker files to use Chainguard images. There are advantages in size and security, specifically when we talk about CVs. Um, there is a large number of images available, including dev variants for you to debug. And some further resources are the Chainguard images directory. And we also have the Chainguard Academy website where you can find some educational resources on how to use images, some tutorials, and information on vulnerability comparison and specific images.
Awesome. Well, thank you, Marin, for an awesome presentation. Did we have any final questions for her as we wrap up here? Don't forget to send your screenshot of your forked and completed demo to Kirby at chainguard.dev to receive your Java surprise. And then our next session is going to be April 23rd with Erica Heidi. So we're very excited about that. You'll receive a recording of this presentation in your email, as well as the the April session, so that you can sign up for that as well. Awesome. Thank you so much, everyone. Have a wonderful day.